We stop there, and we say that from here, this one was Newton's law. In terms of momentum. In terms of momentum. You remember that one? This one is the formula for Newton's law in terms of momentum. We rearrange it in this way because it was like this in the formulas you get at the end of the year. So I wanted you to see it there. All right? Now, there is something. We have from here, we can see F net multiplied by time. Can you see that one? This one, my lovely, beautiful children, is a new physical quantity called impulse. This is impulse. That is a new physical quantity, and it is a very important physical quantity. So please make sure you write it like that. Now, the symbol for impulse, the most accepted symbol for impulse is capital J. J is the most accepted symbol for impulse. However, you can see sometimes I, and you also can use the word impulse. Okay? Now, the definition of impulse, which I'm going to write J, is a vector quantity. We'll speak about that one just in a moment. The definition is the formula. Is the product of net force multiplied by the time for which that force is acting. Right, so now if we go, let me just quickly change the color here. If we go to the unit, what is the unit of impulse? You can see force. Do you remember the unit for force? Which one is? Newton. Newton is multiplying, is the product, isn't it? By time. What is the unit of time? Second. This one is the unit for impulse. The unit, let's write SI, International System of Units, for impulse, is Newton second. Is Newton multiplied by second. Any question there? Okay, so now we go back here to Newton's second law in terms of momentum. Just there. Just there. Look here at this formula there. What is this? What is that I highlighted there? Impulse. So we can say, and I'm going to use the symbol J. We are going to use here the symbol J. Okay? That's it. So J, or impulse, is equal to change in momentum. There we go. This is called impulse momentum theorem. Impulse momentum theorem. So what we have here? Impulse is equal to the change in momentum. This, very important, my lovely. Very, very important. So now from here, if you want, you can work with that theorem. We can say that impulse, but what is impulse? F net multiplied by time is equal to change in momentum. How do you calculate the change in momentum? Mass, bracket, final velocity minus initial velocity. You see? So we end up that we can use this formula in that specific way. All right? This one is impulse. This one is impulse. Let me just move this one there. This one is impulse. And this one is change in momentum. There we go. That is called impulse momentum theorem. Guys, any question up until here?